going to explain would be the how the rehabilitation coach work. It is working based on the principles of allostatic control, which could be roughly explained by this diagram here. In allostatic control, we think about uh, states of the internal environment of the human body. So, for example, here we have three physical and internal states that our body can feel, including physical fatigue, cognitive fatigue, and performance. These are the three, uh, I would say, internal system for internal states that we are working on with our first version right now. But of course, our job is to list down all the possible system that could be modulated. So we represent a number for the X system, which is the line that I have here, the dot line that I have here. So X system will range from 0 to 1, but at the same time, they have a desired range, which we call homeostatic, maximum and minimum here. So whenever our actual perceived value, for example, the cognitive fatigue here, is within that value, let's say from 0.3 to 0.7, and the actual value is 0.5, which means we are safe and nothing will be triggered. So it is like we don't have any problems with cognitive fatigue now. But if it is below or above, then some action must be done to bring it back to balance, like this one. Uh, so we decided based on the input from the environment, here in particular RGS, as you can see these four components, or the exoskeleton or the fats. Whatever input we receive from the shimmers, biosignal, fats, exoskeleton, and RGS should somehow modify this factor, this line, to move it up or to move it down, to change the values of the relevant physical system or internal state. And because of that, we can make a decision to support the assistance of the exoskeleton or the fast, or make the game more difficult or less difficult than that. For example, if the cognitive fatigue is high, which means the patient is tired, so maybe we will try to make the game less difficult. Or if the patient is suffering from physical fatigue, which means that they're having a high fatigue, let's say, so maybe the exoskeleton should provide more support. That is the idea of how the rehabilitation coach work. I can show you the code now. Here you can find in this uh, repository. Um, Go to source, and in this we have a lot of folder here. Which I care about most is the allostatic control, where we have the digital twin, and the allostatic controller, which is the rehabilitation code. So in our digital twin for now, it only have the three number, as I said: cognitive fatigue, physical fatigue, and stress. And what we have to do is to identify all the system, all the variables here, and how can we interpret them from the signal that we have. For example, from the swimmers, from EDA and heart rate, how can you come up with, let's say, stress? Or from the exoskeleton of fats or others variable that we can have, how can we come up with the physical fatigue? And then this will, for now, I only randomize them from 0 to 1, as you can see. But it has to be real number that we receive. That is the first thing we have to work on. Maybe first with MIDAS, requesting data, and try to get a number from that. And then I simply send it to the rehabilitation coach without any further processing. So in the rehabilitation code, after I receive all the factor, which I call AV, because this is the actual value that we can perceive, what we need to do first is to make sure that it will be normalized from 0 0.1 to 1. And then imagining that the cognitive fatigue or the physical fatigue could be uh, somehow improved over time. You will feel less tired over time. So we will have a decay factor here, and we have to subtract that factor from the value we perceive every time stamp, which is done automatically by Ross. And then from that, we will check if the actual value that we have is within or outside. And if it is outside, then we have a value here. For example, this is 0.3 and we have 0.2, then we have a value of 0.1, which I calculate here in the code. And I call this U, mean the urgency. And then in this code, the coach will simply weight the recent urgency that I calculate with a k number, which is the priorities, which is more important than what. Currently, they are all equally important. One, we can discuss if we want to prioritize something or not. Although, in my opinion, it should not be that complicated. It can be straightforward that they are equally the same. And then from that, for example, I can have the uh, difficulty of the game relying on the cognitive fatigue and the stress fatigue. So I calculate a drive based on that, based on the two of them, and divide by 2. And then accordingly, I increase the difficulty or reduce the difficulty. The same we are doing with the face and the exoskeleton. Yeah, so read it in carefully what I wrote here. Um, and how we are currently modulated with the rehabilitation coach. So going back to it, the task we need to do now is that we are receiving a lot of information from SIMMers, from clinical data, from RGS, from FAST, from exoskeleton. And I propose we have another Python ROS node, which is the input receiver, in which we request the data if needed. We receive the output, and maybe at this stage you can process the data. For example, if you can use EDA or PPG to come up with cognitive fatigue, with stress. We have to do it here or in MIDAS, up to you. If you are familiar with MIDAS or you are more familiar with just simple Python code, and we have to do it here. And we send it to the digital twin. So the digital twin will again just store the information and pass it to the coach. What we need to finalize now, and I will write them in the email instead in this video, is what kind of inputs we receive, what kind of variable we will have. For example, here we have many tables. I will repeat it in the email. And how can they represent a system that can be modulated by the rehabilitation coach, and how that system will affect which element of their actuators.